This is a quick video introducing you to the concept of what we call mixed nomenclature. Nomenclature is really just a fancy way of saying the naming of different substances. So mixed nomenclature, mixed referring to the idea that I'm throwing both ionic and covalent substances at you, and your first responsibility then will be identifying either substance as covalent or ionic, and then using those rules that you've learned thus far to give that item the appropriate name. Nomenclature, again, like I said, is just a fancy word for the scientific name that we give to all of these substances based on the elements that make them up. So there are two examples of this practice test card in the folder, and the first thing I ask you to do is just to differentiate between ionic compounds and covalent molecules. Now remember, compounds are ionically bonded, molecules are covalently bonded, and it is important that you remember and use the correct terminology depending upon which substance you're talking about. Ionic compounds are made up of metals and nonmetals. Polyatomic ions also always make up ionic bonds. It's in the name, right? The fact that ions form ionic bonds, so you will never see a polyatomic ion in a covalent bond. Covalent molecules then are made up of two nonmetals, keeping in mind that those two nonmetals, there will oftentimes be more than one of those atoms present, but the elements that make up that substance are always nonmetals. The initial part of this test card then just kind of breaks those pieces up to hopefully make it more easy for you to begin the process of understanding what it takes to first identify a substance as ionic or covalent, and then to use those appropriate rules to work through the name. So we'll just talk through the first couple examples and then give you the rest of the time to finish up this test card and ask any questions that you might have. The first substance that you're given, and I should change that actually, it's not a compound, substance, because they're both mixed, is K2O. So looking first at K, it's potassium. Potassium is a metal, so we'll give it an M for metal. Oxygen is a nonmetal, so that's element number 2. That's a nonmetal. Remember from up above, metal plus a nonmetal results in an ionic bond. And from there then I'll use my ionic bonding rules to give this the name of potassium oxide. Second substance is 2 atoms of oxygen, so the first is a nonmetal, the second is a nonmetal, which results in a covalent bond. And the name here, according to our naming rules for molecules, there are 2 atoms of oxygen present, so this would be dioxide. Okay. Next one, copper is a metal. Chlorine is a nonmetal. Copper is also a transition metal. Make a note of that if it helps, which still results in an ionic bond. And the naming now, you would need to unravel this crisscross to determine what charge copper must have to give us a CuCl2 end formula. You'll find that this is a +2 copper ion, so the correct name would be copper, Roman numeral 2 because it's a transition metal, chloride, IDE. Okay, go ahead and continue working with this. Pay attention for polyatomic ions. I can tell you right away you've got a polyatomic ion in your next example. Also pay attention and be on the lookout for your transition metals, as well as some of the metalloids. Traditionally, if the metalloid is to the right of the stair-step line, it will form covalent bonds. And if it is to the left of the stair-step line, it will form ionic bonds. But remember, there are always exceptions to any rule. So keep working on these. Let me know if you have any questions. I am more than happy to talk through them with you.